Good morning, good afternoon, good evening, depending on where you are. Thank you very much for joining us for our webinar today on EX3. Some of you may be aware and some may not be aware, but about a month ago, April 15th, Rocscience held a webinar on EX3, which gave an overview of the program, ran through several of the features of the program. Today's webinar is a continuation of that series. So today we are going to actually look at modeling an example of an underground mine with EX3. However, we will start off by briefly discussing what EX3 does, and then we'll get into creating a model. Again, my name is Reginald. I represent Rocscience in Africa. What we will do is that we have a presentation as well, but I'm going to demo the software as we go through it. As a result, in order to save time, I have saved at certain stages, which I can bring up just to show you what the result of my actions would have been if we had the time to go through the full thing. This will allow us to be able to finish the webinar within about 40-45 minutes, and then we'll have a question and answer time. And so we look forward to having a great time with you. Thank you very much. If you cannot see the screen for whatever reason, or you cannot hear the audio or anything, just make sure you send us some comments and we will address it and make sure that you'll be able to hear and see everything. So today we will look at building a practical underground model with EX3. We will spend a fair bit of time talking about the geometry, how to import it, how to clean it up, creating groups. We'll look at setting up the field stress states. We will specify a few material properties. What is interesting about what we're going to do today is we're going to include a fault in our modeling. Then once we've done that, we will compute the model and interpret results. This is why I say I've already computed it, so I have results. So when we get to that stage, rather than compute and we all sit and wait for results, I'll just open the file with the results and we will get through the interpretation of the results. So this is how we're going to go through today's webinar. But first, let us start by talking a little bit about EX3. What is EX3? Some of us may be familiar with Examine 3D. So EX3 is the revamped version of Examine 3D, but with many more newer features, more efficient ways of building models and computing them. So we will talk about that in a little bit. But EX3 is based on the boundary element method, which is a very efficient approach to elastic stress modeling. The beauty of the boundary element method is it allows you to discretize, put elements only on the faces of your excavations. You do not have to generate a mesh for the volume of material surrounding the excavations. You only need to discretize the surfaces of the excavations. So it saves you in terms of the size of the problem and in speed. Now, what are some of the new features in EX3? This was covered in the webinar we did about a month ago. But just to refresh our minds, I'm going to talk about some of the features that have appeared in EX3, which give it quite a modern feel. And it's not just about being modern, but it just makes our modeling efficient. So there are new tools for importing geometries. There is a tool we call divide all. Once you've brought in all the geometries, you need to divide all so that specific volumes will be created in the model. There are options for repairing the geometry that you bring in, and those are some of the options we'll look at today. There are also options for meshing the surfaces of the excavations that you bring in, or if you include a joint, of meshing the joint. So these are things that you can do. You can stage the excavations. For today's example, it's only one stage. It was just to quickly get us through the features of how to input joints and do some of these things. But you can do more than one stage. You can also have multiple materials. Commonly, this is very common with backfill. When we've excavated and we want to put it in backfill, or you are in a domain where your hanging wall is different from your foot wall, and maybe the whole body is even got different properties, you can do that in EX3. You can put in joints or large geological structures. And today we'll look at grouping excavations. You group these entities. It just makes things more easy to account for, easy to sequence, easy to change things. So we'll look at that very briefly. And then I just wanted to bring up, there is a feature in EX3 that allows the program to take a full advantage of your graphics card. So if, let's say, you have an NVIDIA GTX, some powerful graphics card, you can accelerate things. Currently, it works for visualization. So when you get to visualizing results and you've turned on the acceleration feature, you can actually see your refreshing of results and things like that much faster. But we are working on allowing some of the computations to take advantage of the GPU. Still in the baby initial stages, but we will get there, where it will be a good part of what we do to speed up calculations. So, brief chart comparing EX3 to Examine 3D. You can go down the list. We can import geometries. We can repair geometries. These were things that were not existing in Examine 3D before. How to improve your surface meshes. Fill points in the boundary element. Once you've set up your model, you need to set up a volume or a plane or a line indicating where you want to calculate your stresses, the points at which you want to calculate your stresses. That was existing already in Examine 3D, and we have it in EX3 as well. Multiple materials, it's unique to EX3 compared to Examine 3D. Joints, grouping. Interpretation of results was in both, and GPU acceleration is unique to EX3. So when do we use EX3? Because in Rocscience, those who are familiar, we have RS3, which is a 3D finite element program. Then, of course, we have 2D programs as well. RS2, the 2D version of RS3, and EX2, the 2D version of EX3. So where does EX3 fit in the grand scheme of numerical modeling when you have linear, elastic, homogeneous materials? And you want to model correctly far-field boundary conditions, because in a finite element method, you need to bound the extents of your model. You need to create a boundary within which you have your excavations and other things you need to incorporate in your model. In a boundary element method, that is not necessary. It correctly models far-field conditions. As a result of the above features that we just discussed, it makes it very appropriate for mine-wide modeling. If you try to do mine-wide modeling with RS3, the number of elements may be quite large, and therefore computation may be much slower. EX3, because it meshes only surfaces and correctly models far-field boundary conditions, can be used for quicker elastic analysis. Sometimes you want to capture the influence of large-scale geological features, faults, shear zones, and you can do that with EX3, even though it's elastic. But when it comes to faults and joints, these discontinuities you can actually measure as features that are plastic, they can fail. So another thing that EX3 allows us to do is, with the elastic results that we get from EX3, we can combine that with some empirical failure criteria, which will allow us to, for example, determine which areas of the model are prone to high stress related issues like rock bursting. So it's elastic analysis, but you can input a criterion. And so we'll look at some of that today, where as a user you can specify certain criteria, and then you can calculate that based on the results. And then you can see what is happening in your model. So this is an example. This, I believe, is coming from Castro et al., a paper they wrote on how you use boundary element modeling for some of these things we've spoken about. And if the brittle stress in ratio that I just showed on the previous slide, if it's less than 0.35, typically you don't have any rock mass damage. If it goes beyond between 0.35 and 0.45, you can get minor rock mass damage, such as surface falling. But as it gets higher, you can get major problems. So with this simple criterion, once you get your elastic results, you can input it into your interpreter and begin to see which zones of your model can experience which levels of damage, if any at all. So we're going to start off by looking at a practical underground mine. I will import some drifts and crosscuts, and then I will also bring in some stopes, and we will model it. Now, as we go along, if you have any questions, you can type your questions in. We have a team monitoring your questions. They'll be answering some of the questions live. At the end, I'm going to go through some of the questions. We can't do all of them, otherwise we'll be online maybe for a long time. So we'll do some of them, but we are going to make this webinar available on YouTube, so anybody who is interested can go and have a look at it. If you are interested in seeing the slides, we can give you a PDF of the slides, and that may be very helpful for you. So, as we said, we will create our model, and we will open EX3, we will import geometries, and we're going to do a bunch of things. I'll take you through all of these steps as we develop the model. So I'm now going to share my EX3 screen. Just bear with me for a second. So I've opened EX3. This is what you see when you start modeling with EX3. And what I'm going to do is I'm going to start by importing in my drifts. If you look at the previous webinar to take you through the project settings and some of the other features, today we just want to try the practical example. So I will not revisit everything that the fine gentleman who presented that webinar spoke through, but I will just show you what we're going to do. So now I'm going to bring in my drifts. I have it saved. The way you import geometry, you can either go through the icon on the menu button here, or you can go through the menu. It's this one and the same thing, but you choose import geometry. Once you import geometry, you can navigate to the right directory. I am in the directory that is of interest to me, so I'm going to bring up my drifts and crosscuts. And so once I select that file, I see this screenshot. And now I can select which of these geometries I want to bring into my model. In this case, I'll select all of them. Once you've selected that, your next step is you click the post-processing button, which I am going to do. So I click my post-processing button. Now, depending on the model that you have, and typically we get these geometries from mine planning from the survey department. Sometimes they are very tricky. They are very difficult to work with. So Rocscience has provided tools for cleaning them up so you can use them in your 3D stress analysis. What a lot of people do is they select, we can find a repair defect immediately. When I have very complicated geometry or geometry that is not so nice, I prefer not to do my repair immediately. I will do it later on. So it's not something that you have only one chance to do. Even if you miss the chance or you skip the chance to do it now, you will get a chance to repair things. So that is what we are going to do. I'm just going to select the entities. I select done, and it's importing them. So they are imported into my model. When they were being imported, I forgot to tell you something. You can specify what entity they will be in the model. Right now, we brought them in as excavations, hence they have this pale default color. But I'm also going to do something. I'm going to assign all of these to what I call one group. When it comes to staging, that can be very helpful. All the excavations that belong to one group may appear, let's say, in the actual modeling as stage 1. Another set appears as stage 2. You can use that to represent your different backfill stopes and things like that. So grouping is a very useful thing. Right now, I'm going to group all of these excavations we brought as what we will call group 1. So I just select all of them. So I clicked on the first entity, holding the shift key, I select the last entity. So it shows all my entities. And then what I'm going to do is, if you look at this part of my screen, the properties pane, there is a grouping item. I'll go to grouping and I'll choose group 1. If I'd wanted, for example, to change the colors of group 1, I could select this, come in here and change the colors. You could set a transparency. So these are things we could do, but I'm not going to do any of those. I'm just using the default settings. So I've changed everything to group 1. So once I even deselect my entities, they still show up. Right now, what you can see, and I will show you how you can turn on the triangles. Right now, it's showing the triangulations of the geometries I brought in. So let's zoom into one of these areas. You can see these triangles here, they almost look like parallel lines. They are actually not parallel lines, they are triangles, but they have very poor aspect ratios. What we have found is sometimes when you bring it in, as we did the first time, and you try to repair things automatically from that screen, these thin sliver elements and the fact that there are so many of them in the model can create issues for the algorithm. It can take a long time. So what we are going to see today is how we can sort of speed up that without sacrificing in accuracy. You can see these triangles because under my view option, I chose show all edges. I had it chosen already. Let's see what happens. It's just a toggle. When I toggle it off, now you see my entities without any triangles. So if you want to see your triangulations, it is important to do that. So I'll minimize this screen a bit just so you can see all the excavations. I had zoomed in just so you could see my triangles, but let me go back and see the triangles. So I'll go back to view, show all edges. Now I can see the triangles again. I zoomed in so you could see the sort of problems I had in some of the areas. So what I am going to do is I am going to re-triangulate. So I select all of these entities. The way EX3 works, which is the way RS3 works, which is the way slide 3 works, is to perform any action on any entities. You first select the entities, then you specify what actions you want to perform on them. So I'm going to select all these entries I brought in, and then I will go to geometry, and then I will select surface re-triangulate. I believe people are asking me to minimize, because you can't see. All right, I am going to move over to a different view. So please bear with me. I'm not going to stretch everything so wide. I was saying we went to surface triangulation, we said re-triangulate, and I'll leave it at the default settings of medium. And I'll select OK. So it re-triangulates the entities in the model. Now what I'm going to do is I'm going to zoom into, again, one of the areas we had previously, and let's take a good look at the triangles. This was the region I had very thin sliver triangles. So re-triangulate has created more sort of equilateral triangles in the system. And this helps with the modeling, even when it comes to numerical accuracy. So that is the purpose of re-triangulation. Now, after re-triangulating, it makes it much easier to fix things. Like I said, when it's very thin slivers and we try to re-triangulate, sometimes we can have a lot of issues. So I have brought in my drifts and crosscuts, and for me to repair them, and I will not repair, but I will show you how we can check for whether there are holes in the geometry, whether there are triangles. Even after a re-triangulation, we can still have a few issues with the model, which we may need to fix. So to do that, you make sure you select the entities again. Remember, in EX3, RS3, all those programs, make sure that. So I'm going to maximize just one of these windows. Maybe that will help. I'll maximize just one of the windows. And then I am going to select all my entities again. I've selected all of them. And then I will go to geometry and I'll go to repair tools and I'll select repair. I'll show you the dialog. I will not do the repair. I'll go to what happens after we have already repaired. But I want to show you how you would do it. And for underground excavations, sometimes depending on the size, the number of entities you are bringing in, it can be quite a task, time consuming, computational time. But it's still, we are generally talking of the order of a few of minutes, maybe half an hour, depending on how many elements you are bringing in. So it's still pretty fast, but I'm not going to hold us up, make us wait. I just wanted to show you what happened. So now there are different categories of defects in the geometry that we just brought in and retriangulated, and we need to fix them. Now, typically, everything is checked. When you do it through repair all, it's sometimes more difficult to select which defects you want to fix and which ones you will wait until to a later time. So that's why I like importing things and then fixing after, because I have the flexibility. For example, I don't worry too much about the holes for now, so I'll turn it off. Maybe I turn off near folding, and then maybe I can leave the rest. So once I do this and I click repair, it will repair the defects that I have left in. There are times where once you fix these defects, it automatically fixes some of the other problems. When you turn on, when everything is fixed, your defect count will be 0, 0, 0, 0. So in our case, I'm not going to go through all of that exercise, but this is how you would fix your defects. So now, once we have fixed the defects, okay, so some of you want me to go back. So let me go back to, you want me to go back to where I imported the geometry? I'll do that. I'll just step back to where I import the geometry. Okay, so I am just going to go back. I will import the geometry. And this is the beauty of RS3. You can always undo. So I will just undo everything. Sorry, EX3, sorry, I'll just undo. So that will take me back to, so now I'm back to my original worksheet that I had opened. So let's go through again. I go to import geometry. I can either select it from here, select it from the geometry menu, or I can even select from the file menu. It's all there. So import geometry, and I chose this drifts and crosscuts. So I imported this geometry. Once I see this dialog, I select which of these entities. It may not always be that you want to bring in everything, but in our current example, I want to bring in everything. So I select bring everything. As I had told you, I can select whether it's a geology, it's a construction, or it's an excavation entity. Currently, the excavations. Then the next step is to select post-processing. Once I am here, I can have a choice of finding and repairing defects. This is what I said we can do from here. But I have chosen to do it later because I know, particularly with this example, that because of all those thin sliver triangles, it's much more difficult to do it from here. It's slower. So I'm happy with this, and I select that the entities I brought in here. Once they are here, I'm going to select all of them. And there are different ways of selecting them. This is not the other way, but the only way, sorry. But I'll stick to this. I select all of them, and then I go to grouping, and I put them all as group 1. It's not an absolutely necessary step, but for housekeeping, for sequencing, for tracking, excavations, types, grouping is very powerful, and it's not just done in EX3. Other programs have it, so it's a good thing to do. I've grouped them all as group 1. And then what I did was I showed you that if we were to zoom in and look at some of the triangles, you can see that these are what seem to appear to be parallel lines are actually not. They are triangles, but they are thin slivers, and this creates issues for modeling. So we are going to retriangulate to improve how the triangles look like. And the way we did that was we went to geometry, went to surface triangulation tools, and selected retriangulate. And for this particular example, I left it at the default settings, but you can do high. High preserves more features, so you get finer triangles. Medium is in between, and low is coarse. So I'll just leave it at the default of medium, and resolution I'll leave it at auto, but we could change the resolution as well. And I'll select OK. So it's retriangulating all these entities. And now that is done, let us zoom in and see again Now see the triangles are much more, the size of more or less similar order of magnitude. Previously, some of them were very thin and long. So that is what we tried to fix. Now, once we've done all that, we also want to see whether there are any holes or any issues in our geometry. So the way we do that is select all the geometry, go to your geometry model, menu, select repair tools, select repair, and it's going to show you what the defects are. So right now it's showing me I have 391 near degenerate features. Again, I refer you to the webinar of April 15th. You can quickly look for that in YouTube. There, Sina and Owen give you some more details on what these defects mean and how you fix them. Like I said, I'm not going to fix them because that takes a little while. So I'm just going to skip that process, but I'm going to show you what happens once we've done that. So here they are fixed. And then what it is we can also now bring in the stopes. Right now we just have the development excavations. We've brought them, we've checked them, we've fixed them, we are happy with them. Now let's bring in the stopes. Here I have imported them already, but I just want to show you how they look like. This is all to save us time, but it's the same process as I had used before. I brought them in, and then let me maximize only this. So I brought them in and I went through the same step of re-triangulating them so that I could get this much more evenly distributed triangles. If I went here and I brought in that, just so you can see that that's exactly what I'll go to import geometry. If I bring in, I believe it's these guys. Let's bring all of them in. And I'm not going to process them. I'll just click done. Now look at the triangles. Again, the triangles are not pretty. So once I re-triangulated them and I grouped them, just as I had done with the drifts, I will go and select all my stopes. And then I put them under group 2. So that's how they became yellow in my second screen. And that's them. EX3 has a feature where you can make things opaque, so they are no longer transparent. So if I just slide my slider here, it gets fully dark, and now you can't see through them. So some of the screens, if you are wondering how come my screen here looks solid, it's because I put my transparency, and you can see here at 100%. But this is what we get after I have fixed the triangles to make sure that they work. And like I said, I have also gone ahead to do repair, but that can be quite, depending on how many entities you bring in, it can be time consuming. One of the things we encourage is you can bring in your geometries in manageable bits, clean them up, make sure they work, and then add more to it. So start simple. That philosophy of always starting simple and adding complexity works even with geometry building. You can do that easily. So we've brought it in. Once we bring it here, let me just go to fix it, try and fix my stopes. So let me select them so you can see again what happens. And instead of selecting them from the tree, I could actually select all of them from the groups. So if you look at my visibility pane, there's a groups tab. And under my groups tab, you see I have group 1 and group 2. I can select everything under group 2 just by clicking at the top of the group. So that's another way also of selecting. There's so many tools we give you to make your work easy. And again, I can go to geometry, repair tools, repair. And it lists my defects. And this one is it's fast enough. Let me just go and click repair this time. So you see that we are not talking about spending hours doing this sort of stuff. It's a minute, but it can be longer. This allows us to see what the software is doing. So it's looking for all of these problem issues, retriangulating, going through a bunch of things. While it's doing that, I will tell you what the next steps will be when it is done. Once this step is done, it means we'll have all the geometry we need for our current model. We have the drifts and the crosscuts, all those development excavations are in. We have the stopes we've brought in. Once we have all of them, we've grouped them. Like I said, we could have even grouped the stopes into secondaries and primaries, and there's a lot of different things we could have done, but we're not going to go into all those details. We just want to capture the essence of it. So once we've done that, we are almost ready to model in terms of the geometry. Remember, we still haven't spoken about material properties. We haven't spoken about in-situ stresses. We haven't spoken about the joint or the faults that we want to put in. We also haven't mentioned anything about the field stress box. So we will add all of these pieces as we go along. But this is just to show you how the software works. So it's almost done with the defect fixing. And once that is done, yeah, there we go. So it's done. And this time, see, there are no defects. Sometimes when you're trying to get all the defects to zero, it can be a bit challenging, but the tools are there with retriangulate and some of the other tools that are in the program. You can get to this stage where you can do all of these and get these zeros quite quickly. And we say close, and now those are in here. So that is what you do. Once all of the geometry is in here, we do what we call divide all. So right now, those crosscuts and drifts, wherever they are not properly intersecting with the stopes that we just brought in. But we need to do a divide all so it can create sub-volumes. Let's pretend that there is a crosscut that goes right through the stope, for example. Once it goes through, it breaks up that crosscut into segments, which means newer, smaller volumes. So divide all, that's the essence of that exercise. And the way you do divide all is, again, there is a button up here. It's labeled divide all geometry. If I select, it will start doing divide all. Or alternatively, I could have gone to the geometry menu and it's sitting at the top, divide all. So once you've brought all your geometries, you've cleaned them up, you're quite happy with what you have, you've grouped them, you've done all those things, you can now go to divide all. If you have questions, you can post your questions. Well, I'm sure some will have questions at the end, but we'll get to them. So in this particular model, I've done divide all. The only reason you're not seeing the triangles is because I have turned it off in the view. I can show the edges, it's there. But let me turn it off. So that's my model. My transparency is set at 70%. So I'm happy with my excavations. They are all in. The next thing we are going to do is the host rock. What are the properties of the host rock? So I'm going to specify them. If you had backfill, we could also specify backfill. The way we do that is make sure we are on the geometry tab. These are the workflow, how we generally go about solving an EX3 problem. You start with geometry, it will automatically mesh. We'll see what happens. You create fill points, loads, but you don't necessarily have to go in this sequence. But whatever you do, you have to finish these steps before you compute. That we know enough. Obviously, before you get results as well, you must compute. But this is generally a workflow tab. So make sure you are in geometry. Once you are in geometry, you can go to define materials, the define materials icon, and specify your material properties. Or alternatively, you could go to the materials menu and select define materials. But that is a choice we have. So here we have our host rock, and we're going to specify properties. Let me quickly move, before touching the stiffness tab, let me move to the strength tab. I am going to specify a uniaxial compressive strength of the intact rock of 100 MPa. That's the default, but in this case, my default coincides with what I want to specify. But you can specify whatever works for you. You can choose different material models. These are the material models we have in EX3. I am going to choose generalized hook brown for this example. For my generalized hook brown, I have my intact rock strength, I have my MI parameter, and I have my geological strength index GSI. So I'm going to select the GSI calculator button, which allows me to see these entities, and I'm now going to specify them. For example, I said UCS is 100, GSI is 65, MI is 15. I'm not doing disturbance factor. If we're doing disturbance, we should always remember the entire rock mass cannot be disturbed. We would have to put a zone around the excavations where the disturbance exists. But we are not going to do that. So for these parameters that I have entered, I see what my generalized Hook-Brown MB, S, and A are. Then the other thing we do is I can specify my Young's modulus. And for this rock, I'm using 40,000. Now, once I select a 40,000 value, this is for the intact rock, and I select OK. If I go back to my stiffness tab, I see that my Young's modulus for the rock mass is lower. So there is an algorithm. If you go to the Hook-Brown papers, it's there. Our intact Young's modulus has been downgraded as well to a rock mass modulus. There is Poisson's ratio. I'll leave it at the default of 0.3, but we could enter anything else we wanted if that's what we wanted to do. And you select OK. So now we have our material properties specified. If I'm sure somebody would ask, what if I have backfill? What would I do? Same-ish method. I'll go here, I'll just add another material. For example, I'll call it backfill. In our model, we don't use it, but I'm just showing you how you can do it. So backfill. And again, the backfill is it's a more Coulomb material, for example. It has a cohesion and friction angle, let's say cohesion of 30, sorry, a friction angle of 30, let's say small cohesion of 0.1 or something like that. And that will be what we specify. So that is what I would do, and I'll select OK. And now I'd have my backfilling. If I wanted to change something to backfill, let's say just this particular entity to backfill, I select the entity, I go to applied property, I choose backfill, and now that will be backfill. So it's that easy. And you could select, I could have selected a group of entities and done the same thing with them. So you have all of these options available to you. So right now we've specified, let me undo my last step because it's not a part of it. I didn't want to specify this as a backfill. Now next thing I'm going to do is I'm going to put in my fault. So the first thing I need to do is, and remember this, I need to bring in the geometry of the fault. If I have a surface that has been mapped and exists in Leapfrog or SERPAC or some package, a DXF surface, I can bring that in and assign that as a fault. In our case, I am going to create a plane. The structure is a planar structure. So let's do that. So first thing is we are going to create the geometry. And the way we go about it is we use the primitives. Primitives are existing geometries that we can just add. So planes, squares or rectangles, spheres, ellipsoids, these are primitives. As most of you have probably figured out by now, you can always access these things either through the menu, 3D primitive geometry, or I could have gone for it straight from the menu bar, create a plane. So I'll select create plane. Now I get this dialog. I expand this section because this is where I'm going to specify the properties of the plane. And I'm also going to expand this section where I specify the size of the plane. So I come in here, I could have selected, if it's a pure horizontal plane, I'll use select XY and it will be ready to go. It will create an XY plane or a YZ or a ZX plane. But in this case, I want to put an arbitrarily oriented fault which dips at 70 degrees. Dip direction is 125, I believe. And so that's what I'm going to do. And because it's a geology, this is geology, I'm not going to use the normals, I'm going to use dip direction. So I switch from normal vector to dip direction. I put a dip, I said, of 70 degrees. Dip direction, I think I said was 125 or 120 or 130. I'll use 125. And the size of the joint. So you see, this is a preview that shows us the joint we are creating so far. But we want to make it bigger. So I want the width to be 700 meters and the height 400 meters. Now I also need to specify the centroid of a point. It doesn't have to be the centroid, but a point through which that fault goes. And so I'm going to select have coordinates I think it's 123,270 for the X, 270. For my Y is 257 and 245. Oh, sorry, I added it together. My apologies. Delete that. So this is done. Over here, I said it's 257, 245. And then my Z, I believe, is 825. So I specified the location. So now I've specified where I want my fault to go through, and I can zoom out and you can see that's my fault. That, well, the plane, I haven't as yet specified it as a fault, but I've created a plane and I say okay. So that plane is in there. If I go into my tree, for example, any new thing added is at the end of the tree. But even in my groups, it will be under ungrouped, and that's my plane. So you can, there are different ways of organizing the entities in the model, and that's what we do. So now I need to specify this plane as a fault, and it will have certain strength and deformation characteristics. So first things, I need to specify the properties. I'll go to my materials menu, choose joints, and go to joint properties. So here I will specify the properties of the joint. My stiffness, I'm going to make it 100,000, 101, 2, 3. My shear stiffness is 10,000, 10 and 1, 2, 3. And I'll leave it as elastic, just so our analysis doesn't take too long. So this will be the joint. If I wanted to add more joints, I could use the add property and add them here. And I say, okay. So now I've specified the strength and deformation properties of the joint. But the program needs to know that this joint, this plane is acting as a joint. And the way you do that is you select the entity as it is selected now. You go to your materials menu, go down to joint, and see there is a menu option, set joint surface. So when I select that, I'm telling the program this plane that I created is now a joint. So I select that, and now it says it's a joint. I could, if I had multiple joint properties, I could have chosen which one would be for this plane. It's the joint one. The joint end condition, the end of the joint, is it open or is it closed? Can it slip relative to each other? Can it dilate relative to each other? That's what this means. And this was the entity we had selected. If we had other geometries, we could have even gone down and selected which geometries we want to be joints. And we say, okay. So that's all we need to do. So now if we go to ungrouped, what used to be plane 2 is now a joint surface, and that's the name. So now we've added our joint to the model. The last few things, we are almost done. We're going to do is specify the in-situ stress state, then specify our field, the box within which we will be calculating field stresses. And as far as the modeling goes, we'll be done. It's quite straightforward. The more you practice, it becomes quite easy. You will realize that most times you probably will spend about 70–80% of your time with your input geometries trying to get them well. And that's not an issue of EX3 at all. It's because of the way we typically get the data. If mine planners or surveyors are able to give you very clean data, it will make your modeling very straightforward. So let's now quickly specify the in-situ stress state. And the way we do that is we go to loads. We go to the loads flow tab, sorry. And then there's an icon here for field stress. Or as you suspect, you can go to loading and choose field stress. We want to apply a gravitational stress state. You know, it's a big mine. The elevations are going from about elevation 700 or 750 all the way down to like 500. You know, it's a big, we're looking at several meters. So we want to go with a gravitational stress field. So I choose gravity. If I have an actual ground surface, I can bring in a surface that we can use as an actual ground surface. We could do that. But in this case, I'm just using an elevation. So for this model, the ground surface is at elevation 1200. The unit weight of the rock is 0.027. And instead of using hydrostatic means my horizontal stress ratios are equal in both directions. That's not what we want to do. We want this one to be, say, 1.2 and this one to be 1.8. And we want to give it a trend. This is the trend of the first horizontal stress. And so I will put it at, say, 35. And we say, okay. So that's done. We've specified our in-situ stress state. In that dialog, we could have gone more complex where it's not just going down linearly. It could follow like what you find Hadley's equations and some of these other equations for in-situ stress. You have the possibility of putting all of that in EX3. But we are done with that. Let us now just put in our field stress box and we'll calculate and interpret our results. So to put our field points, I can go to this menu, flow tab, sorry, and then I can select my add field point box. So let's do that. This time I won't go through the menu option. It's also there, but let's just select it here directly. This is the dialog we see. We have to enter 2 corners of the box and a grid spacing. So that's what I'm going to do. I have some coordinates here that I am going to try and enter 123075. I think is this 123075. This is 257100, I believe. My printout is so small, I forget that I'm aging. So I have to print larger next time. And this, I believe, is 660. Okay. And then this other corner is 123474. 123474, something like that. Doesn't matter. This is 257450. 257450. Yep. And this is 870. 870. So I've specified my box. This is the box I chose. And then I decide the grid spacing for each direction, X, Y, Z. I'll just choose 20, 20. The finer you want your results to look, the higher you have to make these models, these numbers, but then the longer it takes to compute. But that's what we want to do. So once I've done that, this is my field box of points or grid that I have put around my model. And now it's done. All I need to do is save it and run it. But again, to save time, I've already done that. So once you do that and you go to the interpret, this is what you see. You see this window with your results. And now you can choose different quantities. On your screen, I am sure I'll have to move something out of my way here. Okay, so when I go in here, there is a legend and I can choose. Excuse me, because I had done our user data, that is what has happened, but I can view my principal stresses, for example, sigma 1. When I select that, this will be updated, the contours will be updated, and we'll see our sigma 1 stresses. This is along the fault, and this is around the excavations. And we can put horizontal planes through the model. We can put different contour planes so we can see things that way. To save time, I'm not going to do all of that. We can also change our contour intervals. If I right click on the legend and I choose contour options, I can decide to go custom and say I want to see, for example, 0 to 15 megapascals. I could do all of that. I'm not going to do it, but these are all things that you can do in EX3 with interpreting your result. But since we're almost out of time, I just want to show you the last thing is just how do you create your user-defined data? In our case, we call it a brittle stress ratio. So I'm going to show you how we do that. You go to interpret and you choose user data. Select user data. Once you come here, you give it a name. By default, it's just called user data. You choose it, and now you have to specify a function for it. Because it was sigma 1 minus sigma 3 divided by UCS. And right now we don't have UCS automatically input, but I knew the value was 100. So if you're wondering where this 100 comes from, it's my UCS. If you click here, it tells you what the symbols are for the entities you're interested in. Sigma 1 is just called S1. Sigma 3 is just called S3. I put it into bracket and I divide by 100. So that is my brittle stress ratio or normalized deviatoric stress that some people call it. I can change the name to brittle stress ratio. And once I do that, I click done. It will, or okay, it closes the dialog. It computes these quantities, and now I can see it's now on my screen. It is counted up for me, so I can go and see where I have my highest stresses. But in general, when I look at the legend, I do not exceed 0.2. If you remember from the presentation, so now I'll just quickly go back to the presentation because we are done. If I go back to my presentation and I go to this slide, sorry, let me maximize it. That's where those country numbers are coming in from. 0.2 is below 0.35. For the current state of the mine, there is no to minor damage. That's what we would likely see. But it's an empirical criteria. Sometimes these thresholds can change for your mine depending on your rock mass. But these are some of the things you can do with EX3. You can do more. We've just quickly gone through an example, and I hope it's been very beneficial for you. At this point, we'll take a few questions and we will wrap up. So, can you show the direction of K in the worksheet? Oh, so if I'm getting you right, you are asking for this question. If we go into EX3 and we go into, if I'm wrong, please type and make sure we know that I am not answering your question. We are looking at something different. We'll go to our field stresses. You're asking that, do we show the directions of the stress ratio? Right? Is that the question? How do we show that? Sorry, I'm just reading your question so that I make sure I get it correctly. In the worksheet, what do you mean by in the worksheet? Could you explain the direction of K in the worksheet? Do you mean it shows up here as we have the stress box, just as we do in RS2? Is that a question? And there, Tamara, if you are online, could you just clarify that? I don't mind you coming in and speaking to that if that's the question. Now, while I'm doing that, there is another one. Can you add multiple materials as a host rock? So if you want to do multiple materials, like I say, you go to your geometry menu, you select define materials, and I can add. So for example, I can add hanging wall, and I can change the color for the hanging wall. I can make it blue, and then I can specify different properties. 120, 150, 50, 25, something. I mean, whatever it is. Maybe this is 50,000. And okay, and so now I have another. Oh, sorry. In this case, all I did was I changed the host rock to hanging rock. Let me call the second one footwall, and give it different properties. So that's the one I changed the properties for. Let's make this 85 and 17 and 17 or 17, and that's it. It's that easy. So this is how you can specify multiple materials. Will a recording of the webinar be sent out to attendees? Another question, is the BSI included as part of the parameters? In the current version, no, but in an update, it will be added as one of the automatic quantities. So you don't have to use the user-defined route. That will be done. That certainly will be done in the next update, yes. Is the grouping option available in RS3? Yes, it is. Well, not in the version you have. It is still, but there's going to be a release soon. I don't know the exact date, but I believe in the next couple of weeks is more or less the timeline we're looking at, and it will be in there. Is it possible to design BMI in matrix? No, block in matrix works. That's difficult. This is linear elastic. No, EX3 is not for that. Even RS3 would struggle with that. You would have to find some equivalent elastic parameters for that, which sort of reduces, it takes out some of the uniqueness of BIM. But if you have big blocks, if it's just a couple of big blocks, then you can put in the geometry and do that. But you can't do too many of them. It will make your computation a lot more stressful. Okay, so K1 and K2, it will be very useful if we can see it in our 3D sketch. I agree with you. We will have that in soon so that you can actually see that. Yes, that's a good idea. It will be in there. If it hasn't already been done, it will be done very soon. But thank you very much. You've been a very good and enthusiastic audience. I hope this has been very useful for you. This is only the beginning of a series. Let us know your questions, your comments as you try EX3, and we'll incorporate your features. But thank you very, very much, and see you another time. All the best.